Alright guys, welcome to this page of the notes. What we're going to do here is I'm going to take just a few minutes to sort of walk you through how we're going to put together this idea of similar triangles and geometric means. So here we go, right here for this geometric mean theorem. What's going to happen is based on the similarity of right triangles. We already talked about that on the first page of the notes, and you can see it right here, right? I have drawn a right triangle and put in an altitude. What we already talked about is the fact that those two right triangles are proportional to each other, and the two smaller right triangles are both proportional to the overall larger triangle. I'll go through that again with you in here in a second. So similar right triangles created by an altitude to the hypotenuse, which is exactly what we did, right? We just dropped in that altitude. We can develop two theorems involving geometric means. So we're now going to take those two ideas from the first page, the similarity of right triangles, and we talked about how you find the geometric mean, which is the square root, the product of two numbers, right? So I multiply the numbers together, take the square root of them, and that gives me the geometric mean. All right, here's the way that these are going to go. The formulas at first are going to seem a little bit complicated. I'm hoping by using colors to sort of split these up for you guys, it'll help it make a little bit more sense. So first, what I've got here in my diagram is I have the overall bigger triangle, right? So I've got this large triangle right here, which I'm going to outline in red. So there he is right there. There's my big triangle in red. Actually, here, let me fix that a little bit because I ran over top of my X and you can't really see him. So I can let me do a little bit better than what I did. Yes. Yes, okay. So there's my bigger triangle in red. That's my large triangle. What I then do is I drop in an altitude and it splits that larger triangle into two smaller right triangles. And this is the idea we already saw on the front page of the notes. So let me do those two smaller triangles in different colors. I now have this slightly smaller triangle right here, which I'll put in blue. And this other smaller triangle right here, which I'll put in yellow. Now, what we said is that the red triangle, the blue triangle, and the yellow triangle are all similar to each other. And we looked at that on the first page of the notes using the angle-angle triangle similarity. Here's what I want to now do. I want to show you how we can apply those similar triangles and a geometric mean to help us solve for unknowns. So here's what we're going to do. First, when we set up, let me make this quick note, when we set up our ratio so that we don't get messed up or so that it works out for you guys every time, and just to sort of help you keep things straight. When you set up the ratio, what I'd like you to do is make sure that you always put the longer side on top and the shorter side on the bottom. So when you set up your ratio, put the longer side on top and the shorter side on the bottom. Okay, here we go. We're going to go ahead and set up these ratios, and the way that we're going to set up these ratios is by using a side that at least two triangles have in common. So must use two triangles share. Okay, so what are those? Well, let me show you. Here's a great example, right? Please notice. Let's say that I were to use side X, right? X represents just this little part right here, this leg of the blue triangle. is that side x shared by any other triangle? And you might be tempted to say, oh yeah, that part x is shared by the triangle in red. Careful, this side of the triangle, right, this side of the triangle in red is actually that distance c, which would be x plus y. So it turns out that side x is not shared by two triangles. Side x, that side x is only a leg of the blue triangle. So then what is it I am looking for? Must use a variable two triangles share. Well, what about h? Please notice that side h represents the altitude. Which two triangles both share that common side of h? Yeah, it's very obvious now from my colored diagram. The blue triangle and the yellow triangle share that common side of h. So let's go ahead then and set up our proportions. First, for the blue triangle. Now remember, I want to use the longer side on top of the ratio and the shorter side on the bottom. So in the blue triangle, I take a look at my sides, right? And here's what I've got. I have side H, and then let's just say that we use side X. All right, so I'm going to use side H and side X. Now, which of those is the longer side? Well, pretty clearly, H is the longer side, X is the shorter side. So the H will go on the top, X will go on the bottom. So it'll be H over X. Now that has to be equal, right? I told you the blue and the yellow triangle are similar, which means the ratio has to be the same in both of the triangles. So now the yellow triangle, I have side H and I have side Y, which is the longer side. Well, now y is the longer side, so I would have y over h. And just like I told you would happen on the previous page of the notes, please notice what has happened. I've set up my proportion, and the proportion, I have the same variable in both ratios. H shows up in both places. Okay, let's cross multiply. We're going to go ahead and cross multiply, and what I'm going to wind up with is h squared is equal to x times y. How do I get that h by itself? Yeah, take the square root of both sides and look at what I wind up with. H is equal to the square root, h is equal to the square root of x times y. Guys, that's a geometric mean. Remember, we said the geometric mean was the product of two numbers that you take the square root of. So h, this altitude, is the geometric mean of x times y. X the leg of the blue triangle and y the leg of the yellow triangle. This is a geometric mean. Let's find another one, right? Let's find another one. A side that two triangles share. How about A? Which two triangles share side A? Well, please notice side A is my red triangle, and side A is also for my blue triangle. So here we go. First, the red triangle. I have side A, and then what else do I have? Well, I've got this long side right over here, right? They both also share, right? This guy over here. So A, and then this entire length over here is going to be C, X plus Y, but you add them together and we wind up getting C. But which is longer? Well, for the red triangle, C is the longer side, so it would be C over A. That's all going to be equal to, once again, for my blue triangle also shares side A, and then of course I have side X. But in this case, now A is the longer side, X is the shorter side. We always said we put longer side on top, shorter side on the bottom. So this one will be, for the blue triangle, A over X. Well, now that I've set up my proportion, again, A is the same, right, in both ratios, right? They both have the variable A. So we'll cross multiply. what I wind up with is a squared is equal to c times x. Take the square root of both sides, and I wind up with the square root of c times x, or x times c. Remember, multiplication is commutative. It doesn't matter what order you multiply the numbers. You'll get the same answer either way. And again, I get a geometric mean. A is the geometric mean of x, side x, and side c, right? Because I multiply them together, take a square root. That is our definition of a geometric mean. So I see h is a geometric mean of x and y. I see a is a geometric mean of x and c. And I have two triangles that share another common side. Can you see which one it is? Yeah, right here. Side B. The red triangle has side B, and the yellow triangle has side B. So, red triangle first. Red triangle, side B, and then, of course, side C, right? Because both of these triangles share this common side, right? I can't use A because H doesn't share side A, right? So we share side B, and then they both also somewhat share this other common side, although they're not the same length. The ratio will be the same. So for the red triangle, is B the longer or shorter side compared to C? Well, C is the longer side, so C goes on top. B goes on the bottom, equal to, now for my yellow triangle, I have side B and side Y. Well, which is the longer side? Well, in this case now, right, B is the longer side and Y is the shorter side, so it'll be B over Y. And just like we've done countless times before, we cross multiply, we get B squared is equal to Y times C. Take the square root of both sides, and we get another geometric mean. B is the geometric mean of the square root of Y times C, side Y multiplied by side C. Those are our geometric mean theorems. Please look. H equals the square root of x times y. There it is right there. A is equal to the square root of x times c. There it is right there. B is equal to the square root of y times c. There it is right there. Those are our three geometric mean theorems. 1, 2, and 3. And they come from similarite triangles and calculating a geometric mean by setting up proportions. Head on over to the next page of the notes. I'll show you how this works in some example problems, and I'll meet you there.